Rectangular alumina crucible, a high-temperature ceramic vessel made from high-purity aluminum oxide, designed to hold solids or melts during calcination, ashing, and thermal processing in laboratories and industrial furnaces. ADCERAX manufactures rectangular crucibles in capacities from 5 milliliters to 1,000 milliliters in alumina purity grades from 96% up to 99.7%, with all dimensions machined 2 plus or minus 0.1 millimeter tolerance. For material properties, make alumina the right choice for this vessel. First, maximum service temperature up to 1,700 degrees Celsius depending on purity grade, covering the full range of calcination and ashing work typically run at 550 to 900 degrees. Second, chemical inertness. The dense alumina microstructure resists reaction with organic residues, oxide powders, and inorganic salts, protecting sample purity during high-temperature cycles. Third, stable geometry across repeated heating and cooling cycles, with no warping or dimensional drift that would compromise tear mass on an analytical balance. And fourth, the dense microstructure in high-purity alumina surface keeps sample contamination near zero, which is critical in gravimetric procedures where the measured mass is the result. For design, features of the rectangular geometry make this crucible practical for laboratory workflows. First, the flat base sits directly on any furnace tray or setter plate without wobble, rolling, or the need for support rings. The crucible stays exactly where the technician placed it. Second, vertical walls meeting the base at right angles make sample loading predictable. Powders spread evenly across the base, and depth of fill is visually consistent across a batch. Third, the rectangular envelope aligns naturally with furnace rack grids, so multiple units can be placed in labeled row and column positions for sample traceability. And fourth, every crucible is machined to the same plus or minus 0.1 millimeter outer envelope, which means they sit in identical positions on standard alumina trays and fit any rack designed around their dimensions. The typical application for rectangular alumina crucibles is gravimetric ash content analysis, the laboratory procedure used across food science, fuel testing, polymer characterization, catalyst research, and environmental analysis to determine the inorganic residue left after a sample is burned off at high temperature. The workflow is straightforward but precision critical. First, an empty crucible is pre-fired and weighed to establish a stable tare mass. Second, the sample is placed into the crucible and weighed again on an analytical balance. Third, the loaded crucible goes into a muffle furnace typically held at 550 degrees Celsius for food and biological samples, 815 degrees for coal and coke proximate analysis, or up to 900 degrees for polymers and catalysts for 2 to 4 hours until all organic matter is burned off. Finally, the crucible is cooled in a desiccator and reweighed to calculate the ash residue as a percentage of the original sample. Two properties of the rectangular alumina crucible make it reliable for this procedure. The dense alumina body holds a stable tear mass across repeated firings without absorbing moisture or losing material, so the tear subtracts cleanly from every measurement. And the chamfered rims, combined with robust foam-protected packing, cut the handling breakage that interrupts ashing schedules and forces rush reorders. The result is consistent gravimetric data, batch after batch, experiment after experiment.